Okay, hi chemistry students, this is Mrs. Herrick, and I wanted to make a video of the lab where we're going to be burning snack foods and finding out the energy content through the lab. But on the back of the package, it shows that there's 430 calories for this entire package of food. So later on, after I'm just taking the video of the lab itself, but I'm going to have a part 2 of the video for the lab math calculations if you miss the next day of school. Okay, but this is a type of French onion chips, and a lot of kids did other types of chips, but we're going to use this type. But we're going to be working on this worksheet, so you should have a digital copy of this or a paper copy already. But pretty much I walked through the steps with the kids, and they went through all these steps on the procedure. We're going to be massing water, and we're going to measure out water in a cylinder, but we're going to be putting into this pop can, and the pop can is going to be like our styrofoam cup, even though it's not really good. It takes in a lot of the heat, so that's going to be part of our air. We're going to take a certain amount of water in here, and we're going to put our paper chip on, our potato chip. It's a long day, so sorry if I make mistakes in my video. We're going to take a chip, and some of these chips are kind of small, but we're going to go ahead and put it on this platform here, and we're going to light it and then see how much energy comes off from the flame once we burn it. Okay, so I'm going to put it on here, and we're going to light that chip, and we're going to see how much flame heats up this water. Okay, now what we're doing on our paper is we're going to be filling out the information about the can by itself, the can with water, and then we're going to subtract these two, in order to get the mass of the water. And then we're going to actually mass the food itself, we're going to burn it, and then we're going to have a final mass of our burnt food, and we're going to subtract that to get our mass of our food. And then we're going to take the initial temperature of the water and subtract that from the final temperature to get the change in temperature of the water. And so we're going to actually talk about how we're going to do the math here probably at the end of the getting data. So I'll talk more about it later. But I wanted to have you have this part of your paper out, since you don't really have to worry about thinking about the procedure, because I'm going to just do the procedure for you, okay? So have this page out of your lab while I'm doing the video, okay, while you're watching it, okay? Well, the first thing we're going to do is that we're trying to get the water into the can, and we want to get it massed, okay? So we have this pop can, okay, and we're going to be putting and massing this. So I'm going to go mass it, okay? And you want to listen to me orally if you can for the numbers, but I'll try to write it down on my paper as well. But it's 1558 grams. 1558 grams, okay? And then we're going to be adding 50 mils of water, and it doesn't have to be exactly 50, it could be under or over, because we're going to get its mass recorded. So right now I'm getting the water out of the sink, which I'm not moving the phone at the moment while I'm videotaping, okay? So I'm just getting an amount of water, and again, it can be above the 50 mils on the mark or below, it doesn't really matter. I've got about 48 or so. So we're going to pour that into the can. Again, because we're going to get the mass of the water in the can, okay? So I'm going to pour that into the can and then get the mass on the balance with the water, okay? So I'm going to do that, and I'm going to share the numbers with you here in a minute, okay? It's 6280 for the can with the water. So your two datas are 1558 for the can, 62.80 with water. And then we want to subtract the two, which I'll do later, but you can take 15 away from 62, okay? And put that number right there. Okay, next what we're going to do is that we want to know how much we have in this chip. And I'm actually going to go back in the bag and see if we have a bigger size chip, because I really want to make it bigger than what is there. And a lot of these are the smallest pieces pretty much, but I've got this one's a little bit bigger. So we're going to use this chip here, this size chip, and we're going to mask that on the balance. Let me go ahead and make sure it's zeroed. It's zeroed, it's good. Okay, and then we're going to write that down, and that's 0.71. That's 0.71 for the food mass. 0.71. Okay, so that's what you're going to put there on that space and your paper. Okay, so we have the mass of the food, and I'm situating it on the little stand. It may not stay there too well, but if worst comes to worst, I can actually hold it with tongs if I have to. Okay, so I'm just going to leave that there for a second while I'm getting the other equipment set up. It's not staying very well. Okay, so we're going to put the can, it's masked. This can is masked with about 46 or 47 mils of water, and we're going to situate it here on the ring stand using this this stirring rod, which my phone is kind of diagonal there. So we're using this stirring rod to hold the can, okay? But I'm going to move the phone a little bit back so you can see the actual reaction, okay? So we're going to actually light this chip, and that's going to give off food energy, and that energy is going to make the water in the can warmer and warmer and warmer. So we got to get our thermometer to get a thermometer to record the temperature, which I'm going to go get one real quick because I thought I had it beside the equipment. So let me do that. And so I had to go get a thermometer, sorry for the delay, but now I have my thermometer, and that's air temperature here. But I'm going to go ahead and measure the temperature of the water in the can. And we're going to try to keep the thermometer you know, in the water, but not necessarily touching the can. So let's just wait a second. You can see how the temperature is fluctuating a little bit, going a little bit lower, but we want to make sure we have the right temperature for our water. So I'm kind of letting it hang there for a minute. It doesn't seem to be changing. So I think we need to write down our initial temperature of 21.1. Record that on your paper. That's the third column from the end. Okay, I'm going to go ahead and take this out and put it on the counter. Put my phone down so you can actually see the setup. But we're going to put 21.1 on the initial temperature. I'm sorry, I didn't get it over to quite enough. So 21.1 for the initial temperature of water, and that's degrees C. Okay, so you should have these numbers filled in for now, and then we're going to go ahead and light the food. Now that's the fun part. So a lot of the students asked me if they could do it again, even on Tuesday if we wanted to, because we're going to be working on the lab calculations. So we could even do it on Tuesday for you so you can actually see it happening. Okay, now the one thing about the lab is I explained to everybody that you want to try to have the can further down, closer to the chip, so that all the heat is going to travel, you know, into the water in the can. So we want to have it closer to the can, and then we want to have paper available because we're going to collect all the leftover parts of the burnt chip afterwards. So we want to have a piece of paper ready to collect that, okay? And now we're just going to go ahead and light it. I got to get some lighters. Hold on. Going across the room here to get one. We used so much of them today that we probably ran out of all the juice in the individual lighters. So I'm trying to get one that works. Okay, got one that works. Good. Okay. So we're going to light it up, and we want to go ahead and have the thermometer inside. So as I'm heating, I'm going to try to record the temperature as I'm burning the food, and then I've got in the can. So at the moment I can't really move the phone right now. I'm trying to get this, and you can actually see it burning. Okay, so we want to try to see this, and I'm also watching the temperature. So we're going to watch the temperature here. It's already going up. And then I also want to have the, I'm sorry for the movement here. I didn't mean to do all this movement, okay? And sorry again for the movement. But I want to go ahead and keep it lit up. I'm also watching the temperature here. It's over 30 now. Okay, it's over 30 degrees. And I want to see if the whole entire chip is burning, and it looks like it is. So it's getting hotter and hotter. It's getting up to the 30s, 30, almost 38. But right now it's really burning. You can see how it's burning on the other side of the chip there. It's really doing well to do the burning here. And we're also seeing the water going up. So I want to keep it in there. And I want to get this chip as close as I can to the water and to warming up the water. And I don't want to touch the can. I want to make sure it's in the water as the water is increasing in temp. Okay, now it looks like the fire is almost out. So I want to show you the temperature here. It was actually 42.6. And I just grabbed that temperature while I moved the phone over. But we're going to put 42.6 as our highest number. Yeah, right there's 42.6. Actually, the thermometer went off. So let me make sure it's on. Yeah, 42.6 was our highest number. And that's what it seems like our water is even right now, 42.6. I haven't seen it go any higher. So we're going to use that as our final temperature. Okay, 42.6. So let's go ahead and write that down. We had it from 21.1 now to 42.6. Okay, and let me explain a little bit that I could try to tell the others at the end of class on Friday, okay, which is the day that we did this in October, okay, is that we're going to take this amount, and that's going to help us get, you're going to subtract these two, but it's going to be 62 minus 58, and get a number here. I don't have my calculator with me, but go ahead and do the math. 62.8 minus 15.58, and put that number there. And then we're going to do 0.71, and we're going to get the final mass recorded. I didn't quite do that yet. I'm going to put the phone down here in a minute to do it. And then you're going to take 42.6 and subtract 21.1. So also you're going to be subtracting these two to get that value, and you're going to subtract these two to get that value. And then you're going to be using this part with this calculations. And we actually got to step 1 today, and I want to make sure you got to step 1 before you came into class the next day, which would be Monday for many of the kids that are watching this, unless, you know, because in the future years, it would be the second day of the lab, okay? But what's going on is the snack food is losing heat as it was being heated, and that heat was traveling from here up to the can. So this food was losing heat, and then the water in the can was gaining heat. So on your paper, write the heat lost of the snack food is the same as the heat gained by the water, okay? And what that means is you're going to be taking all the information from the water. You're going to take the water mass, and you're going to put that down here for the mass. Also, this is a typo with this extra C. We're going to cross that out, and we're going to record the mass here, the mass of the water. So in a minute, I'm going to get a calculator and show you the numbers, but you're going to subtract 62.8 minus 1558 and put that number there. The actual C constant for water is 4.184. Go ahead and put that in there. That is the capacity for water. And we're trying to find out the MC delta T of our water. And that's going to equal, because all the energy gained by the water is supposed to equal the heat lost by the snack food. So we're trying to find the information of the water, the three things. And then we also have the 21 from 42.6. It looks like it's 21. It looks like it's 21.5 from what I can tell from just doing it in my head. I'm going to double check it with a calculator. Now I'm going to put the phone down because I have to still mass the final mass of the burnt the burnt chip. So let me go do that and put the phone down, and we're going to mask that chip. Now it's kind of sooty with a lot of black soot, so we want to make sure that we can get all that black soot left over and put it on this paper, and we're trying to get it all off there, okay? And then this is going to be masked. This is the leftovers, and we're not going to count this mask because it didn't all burn away, okay? It didn't burn and become, you know, the products of a fire, okay? So we're going to come over here and mask this. I'm going to zero out another sheet of paper because I don't want to put all this black powder on my balance, okay? And we're going to zero it and put this mask on here. And it looks like it's 0.15. That's the leftovers, is 0.15. Okay, I'm going to write that down, and then I'm going to grab a calculator real quick too. I didn't have one nearby. Sorry for all these things not ready, okay? But we've got a calculator now. So here, go ahead and put the, you got 0.71 to start with our food, and then 0.15 with what's left over after it was burnt. And we're going to subtract these two. 0.71 minus 0.15, subtract those two, okay? So let's do that. We're going to subtract all these numbers here. We're going to subtract these numbers to get this, subtract these two to get this number, and we're going to use this number on part 2 of my video, okay? So we're just getting to doing step 1 in our calculations today. That's as far as we got on day 1, okay? But let me help you do the math here with subtracting. I'm sure you might have already gotten it already, which you should have done, but in case you didn't, let me do this real quick. 62.8 minus 15.58, and we're getting 47.22. Okay, that's the amount of grams of water. Okay, and then we're going to find out how much mass we have left of what did burn with the food. 0.15. Okay, and we have 0.56. Okay, so we're going to use that number later on like step 3 in our math. Okay, but we're going to use this number, 21.5. I'm going to make sure I did my math right. 42.6 minus 21.1. And I'm getting, oh, it's actually 30. No, I messed up. That's not right. I did 52 wrong. Hold on. It's 42.6. I messed up. 42.6 minus 21.1. And I'm getting 21.5. So I was right with that, okay? So we're going to take our mass of 47. That's the mass of the equation, 47.22. We're going to times it by 4.184 and times it by 21.5. You guys do the math and come up with your number and have that ready for Monday, the next day of school, in this particular season, this year of school. Have that ready to go when we get together on our next day of class. And we'll start from there. We're going to be talking about the other page. We'll be talking about all this step 2 and 3 and 4. We'll be talking about that during the day on the next day of school. Okay? See you then. Bye-bye. We'll do this part on a second video. I'll have that set up and loaded for anybody absent for both days. Okay, talk to you later. Bye-bye.